Look at that. Do work. Whiteboard! Power Armor project. Let's get it going. Okay, I have a whiteboard now, so that's going to help a lot with illustrations. Okay, main thing, Nitinol seems promising, in the most part. One thing that I've learned through the experiments is that a safe level of stretching for the Nitinol. Let's do this. Nitinol. That's not an O. That is, let's see. Total length is approximately, let's do one, well, realistically, it stretches back almost to the original stretch while it's not under load. But under load at 7.5 ounces that we have experimented with stretches back from a good 1.5 times its original length. So it goes back. Realistically, I'd love to have it go back to its original length from being stretched to twice its length. But there's a little bit of a thing to that. But it's nothing to worry about for right now. Right now, I have another experiment that I'd like to do, and that is boss, and then coil, coil, another negative boss, and then we put our load. So here we're going to see how much that these 3 wires are going to hold. We know how much 1 wire does. That's okay. The thing that we want to test is if it is a linear, it should be linear, because why wouldn't it? Or we're going to have some future problems. I don't want that. We'll have to see. So the main thing that we're going to do is first I'm going to test real quick, do some experiments with insulating them. I have 2 different insulators. All right, so there is this plastic peel coat rubber coating. Obviously it's not good because it's the peel coat stuff. You know, you can peel it. It's not good. And then enamel. Not great. It's not ceramic coating like you do have with magnet wires. But it's better than nothing. Now, the reason I went to test if coating them will work, obviously coating them is going to work, but I want to see the repeated stress of how many times we can stretch, go back, stretch, go back, stretch, go back with it, especially if it's rubbing against each other, because if that's not going to really work, I don't know how this is going to, which is this. Now, this may look like a big black line to you, but this is like a cable management wire. It's nylon, and the cool thing about it is, so I said earlier about those pneumatic air muscles with the nylon sheathing. This is it. How it works is very simple. You have, where should I put this? Can you see over here? I don't know. Let's do it right here. Wow, okay. I'm gonna come on the other side. All right. Hello. Not sure how well you can see this. See me, but I think you can see this. Sorry for the cut. Gotta save space or time, really. All right. So how these artificial muscles work is you have a pump or a syringe, you have a transfer tube, or you could just hook the expandable material like a balloon directly to this guy. And then there is the fiber mesh, this. What happens is when you push the pump, the fluid or air travels through the transfer tube into the expandable material, balloon, into the fiber mesh, this, which then causes it to do this. Come on now. Here's the original length, and then if I press carefully, look how much that contracts. So instead of this nylon, it's going to be Nitinol, but also much smaller. so that it's well, it could be this size too. Who knows how many like actual fibers is in this, but I have come out to this idea. So realistically, the amount of nitinol wires or coils we're supposed to have, oh, I should probably, so the amount of nitinol wires we're supposed to have are probably going to need to have to lift, let's say, 10 pounds. We're going to need 25 wires. 25 wires, 25 times 7.5 is about 180. Why did I write it like that? What am I doing? 180 OZ ounces, which is more than, or about 10 pounds or so. More than 10 pounds. So I think 10 pounds is 160. So we'll probably need 23. But 25 is good overhead to just have as extra force. So with that, that pretty much leads to into our next experiments, which is going to be this, to see how many cycles one of these wires can go through.
Well, there's nothing really to add to this. I just kind of spray painted it. You see me here swinging it around the air to kind of make it dry faster. And that was it.
Question is, how am I going to put what I put up on the whiteboard into reality? With this. I got one wire. This is, I believe, uncoated. This is the enamel coat. You can tell because it's red. And this one is the Plastipeel. That was called? Yeah. Peel off, whatever. This is, well, it's black, but. And then I got 2 bus bars of copper wire. These are not soldered, they're crimped. So, and I can tug on it and it's not gonna come off. And we're gonna do the same experiment as before with the bottle. The bottle. So we're just gonna do all that. I'm going to assemble it real quick. Ta-da! This is stupid. But hey, if it works, it works. Realistically, if we were to continue with these experiments, of course, I'm going to need a way to make a device that just makes these coils quickly. Not quickly, but efficiently and with consistency. Because we got this tiny one, this awful one, and this good one was really long, which is good. I want length when it comes to this because it's got to be basically the longest muscles is going to be in the legs. So we gotta figure that out, how we're gonna really achieve that, well, with this, because this actually, when I stretch it out to a good 1.5, quit moving, its length, it comes out to about my femur, which is good. Then again, I'm not a very tall man, unfortunately. Alright, so I got this all set up, and I decided to have a nice hoop here. Thankfully, turn this around a little. Thankfully, I got a bunch of these alligator clips from China, and they were so cheaply made, I could just instead use them as a clip and use the rubber as, well, this. Alright. Little bit. Okay. Well, all in one take because I hate when people do jump cuts. So try to do this fast. This alligator clip here, which is connected to the power supply, is going to act like an artificial limit, which is good. It's exactly what I want because that is what's going to be needed. Arrgh. Wiggly boy. Get over here. Yes, stupid wiggler. Okay. happens if I let go? Well, they're not stretching out too far. Actually, they're not really stretching out much, except that one on the side. Let's apply power, shall we? It's twisting. Where are you twisting? Okay. Well, that didn't work out so well. Actually, it technically did. Ooh. Okay. Alright. Now we're close together. Sorry, hit the camera. Stop telling me things, phone. Let's turn up the power a bit. Just a smidge. 2.5 amps. Now the thing about electricity is it likes to take the path of least resistance. You probably hold this up. That's gonna shock me. It shouldn't shock me, but it will. I only fear that it will. I only chose copper because it's conductive. Alright, found a piece of... Ooh! That'll work. Yeah, look at that. Stretch out and then... Ah! Right when I turn it on. Yeah, I think the main problem is they're all unequal length. But the main thing is, this is the original weight that it was carrying before and how it stretched out almost all the way. But look now, they're not stretching that far. And if I were to stretch them out like that, artificially, oh boy, hook around. Now, in the end, they're going to be powered individually. That is going to be very important, because if they're not, electricity takes the path of least resistance. So who's the least resistant here? I'm not actually sure. It could be this one, or this one. Who knows? So one of these is going to get unequal heating than the other because it's not actually receiving power. Ah, damn it. All right. I'll have to review the footage. So I was too busy keeping it up. But that seems successful. I'm going to be 100% honest with you. This might just work. Now, the problem is the 25 wires that I'm going to need for this. That's just for 10 pounds. So I need to make these guys really, really small. We'll figure it out in the end. All right, well, here is my leg analog. It's got 1x4 and another held together with a pin. And I got two of these guys dangling. They're a little extended, but that's okay. That's good, because then we can do this. Look at that. Do work. Yeah. Ooh, that was a lot of pressure on this guy. Flung right off. Hey, look. He returned right back to the way he was. This is the, Plastidip peel coat. This is the peel coat one. You see how it raised back up. And now it's back down again. You can see it's slowly moving way back down. But yeah. Hold on, let's see if one does it. Hold it. It's kind of stuck. Oh, that one burst too. Ha! Yeah, these guys actually have a lot of force on them. You know what I need to do? I need to get a... whatchamacallit. Alright, so. Off the recap here. We have our 3 wires there. 2 are coated, 1 isn't. The red one is the enamel. This guy here is the peel coat, or the automotive plastic spray, rubber spray, and this side is uncoated. That worked with the bus bars and the wires and the load. That worked actually really well. And we saw at the end here the fulcrum, or the leg. Yeah. Pivot, one end, other end, and then we kind of connected them together. Not accurate to what was there, but it's whatever, it works. So the main thing for this guy is, in the next video, what we're going to do is make a better leg, make something that we're probably going to use a lot more, mainly because a major goal of this project is to, in the end, not have anything protruding. No cables, no pistons, no hydraulics, nothing. Nothing on the outside. So probably what we're going to do is, as close to the knee as possible, or at the knee, have it connect somewhere around here and just be able to pull directly. It's like how our legs work. It's not efficient when it comes to power, but the reason why we didn't evolve to have our muscles to be strung from our hip to our ankle, like directly, is because it's a target for life and whatnot and other stuff. Bad. It's bad. It's the main thing. It's bad. So we're going to do it somewhat like this. Another thing in the next video is going to be a way of making these more accurately. Making them, well, consistently. They're all going to be the same length, and they're all going to be the same just in general. Not like, the good, okay, and the ugly that we got going on here. In the end, that's pretty much it, actually. The only thing that I'm kind of worried about is making all the wires that I suspect is going to be for getting to that 10 pounds. Because I have a 10-pound dumbbell that I want it to do. But we're going to have to get there at some point. When? I don't know. Maybe next video. Hopefully. Probably not next video. Who knows? So, another thing I gotta do is make better connectors. This is fine. Kind of. But the main thing is, maybe in the next video, what I'll do is have them individually powered. It's gonna be a little bit of work. But, in the end, what we're basing this off of, the Inner Sphere Standard Power Armor, there's a lot of room to be building things. It has a very, very, very large backpack. Most of it is meant for jump jets, but we're probably not adding jump jets for another 30 years. Or maybe we could do it by the end of this. Who knows when that will be? Probably a few years down the line, or a few months. Who knows? I don't have a major workshop. But here it is. Got our 3. That worked well, especially at the end when they jumped off like that. These guys hold a lot of tension. And I'm surprised that it actually returned all the way back to its original self. Well, I'm not really surprised. I think it's the fact that it wasn't overstretched and it wasn't overheated. So that's a big plus. How we're going to make sure that these don't overstretch, I don't know. I mean, there's physical limits, of course. And with this, it's only so far it will stretch. We'll figure it out when we get there. But I hope you enjoyed this episode of Small Beginnings. We're going to get up there. We're going to start getting faster and faster with this stuff. More and more stuff being done. It just all takes time and just got to really work through it. But I hope you enjoyed this. Yeah. This is fun. I'm having fun. This is great. I hope everyone enjoys this. Okay, bye.